So in 1972, they let me publish a big review in pharmacological reviews called Purinergic Nerves, in which I really collected together every scrap of evidence in every system I could find for NANK nerves and for the possibility that ATP was the transmitter in these nerves. But unfortunately, hardly anybody believed it. There was a huge resistance for more than 20 years following this paper. And I think that I can understand it in a way, because really ATP belonged to the biochemist. It was an intracellular energy molecule involved in the Krebs cycle and many other metabolic processes. Why should such a ubiquitous molecule be an extracellular signaling molecule? I think that about 80% of the opponents, maybe 60%, it was just an emotional rejection. It didn't seem possible. They never bothered to read the papers even. It just seemed so unlikely. Another component were very objective. I accepted they said, we don't know whether it's right or not yet. We don't think there's enough evidence to support such a major idea, and we're going to sit on the fence until we're convinced. Von Euler had a Nobel Prize for discovering noradrenaline and gave me marvelous advice. He said, Jeff, I don't know whether the hypothesis is right or wrong, but negative people don't stay around for long, so don't worry about that. You must be objective. When there's new data, look at it carefully. See if it fits your hypothesis, see if it could fit another hypothesis. And if your hypothesis is wrong, you should be the first to say it. So what this hypothesis said, that ATP is stored in vesicles, which migrate to the surface during an action potential and release the ATP by exocytosis, which then passes the synaptic cleft to act postjunctionally on receptors that we know a lot more about now. And then the ATP is broken down by ectoenzymes, by ATPases, first to ADP, then to AMP, and then to adenosine. And adenosine is taken up by a high-affinity uptake pump and reconstituted into ATP cells for further use.